Hey everyone, welcome to another deep dive. Today we're going to be taking a closer look at boron.
Boron.
Yeah, boron. I know it might not sound like the most thrilling element at first glance. You mostly just see it as this boring brown powder, right?
Right.
But trust me on this. We've been digging into the research. I got some fascinating papers and studies here. And let me tell you, boron has a few tricks up its sleeve.
Really? Like what?
Well, for starters, it's not as simple as it seems. I mean, is it a metal or is it not?
It's a metalloid, right?
Exactly. It walks that line between metal and non-metal, which actually makes it incredibly useful for all sorts of things.
Yeah, you see boron in everything from like household cleaners to high-tech applications.
Seriously, the range of uses is kinda mind-blowing. But before we get into all that, can you give us a quick breakdown of what makes a metalloid a metalloid?
Basically, imagine you've got this spectrum. On one end, you have your classic metals, right? Shiny, great conductors of electricity, like to lend out electrons when they're bonding.
Okay, makes sense.
Then on the other end, you've got your nonmetals. Totally different vibe. They're usually dull, not into the whole electrical conductivity thing, and they'd rather snag an electron than give one up.
So where does boron fit in?
Right in the middle. It's like the ultimate fence sitter of the periodic table. Boron's got this weird ability to act like both, depending on the situation.
So what gives it the split personality?
Well, it all comes down to its electrons. Now, I don't want to get too technical here, but most atoms, they're all about having a full outer shell of 8 electrons. They're obsessed with that.
The octet rule. Right.
Exactly. It's like their version of having a perfect Instagram grid. But boron marches to the beat of its own drum. It's perfectly happy with just 6 electrons in its outer shell.
So it's a rule breaker from the get-go.
You could say that. And this rebellious streak, this willingness to bend the rules, is what makes boron so incredibly interesting. It leads to all sorts of unique properties and unexpected uses.
So boron's this rule-breaking element with a flexible side. Where do we actually see it in action?
Well, you might be surprised to learn that you've probably encountered boron in your own home.
Really? I don't think I have any, chunks of boron lying around.
Not chunks, no, but think about borax.
Borax, like the laundry detergent booster.
Exactly. Borax is actually a boron compound.
Wow, never made that connection. So boron's helping me get those grass stains out of my clothes.
You bet. And it doesn't stop there. Remember Pyrex, those glass containers everyone seems to have in their kitchen?
Oh, yeah. Pretty sure my entire bakeware collection is Pyrex. Durable stuff.
Right. And that incredible durability. You can thank boron for that, too. It's used in the manufacturing process to make Pyrex heat-resistant and tough.
Okay, so from laundry rooms to kitchens, boron's already proving its worth. But it gets even more impressive, right?
Oh, absolutely. We're just scratching the surface here. Think about boron carbide.
Boron carbide doesn't sound familiar.
Well, it's incredibly hard and surprisingly lightweight. We're talking like tougher than steel.
Seriously, what do they even use something like that for?
Well, it's used in things like tank armor.
Tank armor. Okay, now that's impressive. What about
Yeah.
that boron nitride you mentioned earlier? What's that like?
Oh, boron nitride is fascinating. It all depends on its form. One form is actually a fantastic lubricant.
Really? So it's slippery.
Incredibly slippery. Even more so than graphite.
Graphite, like in pencils.
Exactly. That's why pencils glide so smoothly across paper. But here's the thing about boron nitride. It can also be incredibly hard.
Wait, hold on. Slippery and hard. How does that even work?
It's all about how the boron and nitrogen atoms arrange themselves. In one form, they create this slick surface, perfect for reducing friction. But in another form, they bond together in a super tight structure that rivals the hardness of diamond.
So boron nitride is like the ultimate multitasker. It can lubricate engines or become tough enough for industrial tools.
Precisely. It's adaptable like that. But boron's talent for exceeding expectations doesn't stop there. We see it in the way it forms molecules, too.
What do you mean?
Well, think about typical molecules. They usually stick to the rules, forming bonds with 2 electrons each. Pretty standard stuff. But then boron comes along, and it's like, nah, I'm good with 6 electrons, even if it means sharing with multiple atoms.
Wait, so it breaks the bonding rules, too?
You bet. And these unconventional bonds lead to some pretty wild molecular structures. We call them boranes.
Boranes, huh? What's so special about them?
Well, they're kind of like the rebels of the molecular world, forming these unusual shapes and structures you wouldn't expect. A good example is diborane.
Diborane. Okay, I'm trying to picture this. What does it look like?
Imagine this. You've got 2 boron atoms and 6 hydrogen atoms, all trying to link up. Now, in a normal molecule, Each hydrogen would have its own bond with a boron atom. But diborane does things differently. It has these bridging hydrogen atoms that connect to both boron atoms simultaneously.
Whoa, so it's like they're sharing a hydrogen? That's pretty unusual.
It is. It's called three-center two-electron bonding, and it gives borane some pretty unique properties. For example, diborane is highly reactive and packs a punch when it comes to releasing energy.
So what's that used for, something so reactive?
Well, it's actually found in rocket fuel.
Rocket fuel. Okay, boron is on a roll here. But we can't forget about those carboranes you mentioned, right? The ones that form those crazy cage-like structures. What are those used for?
Carboranes are amazing. Those unique shapes aren't just for show, though. They actually make them incredibly stable and resistant to heat and chemicals. So scientists are exploring their potential in everything from pharmaceuticals to advanced materials.
Okay, so we've gone from laundry detergent to rocket fuel to cutting-edge medicine. It sounds like boron is a jack of all trades.
It really is. And we haven't even touched on its isotopes yet.
Oh, right. Boron's got those different isotopes, each with its own personality, just like you were saying before.
Exactly. And those isotopes are where things get really interesting.
Okay, remind me again, what's so special about boron's isotopes?
Well, you've got boron 10 and boron 11. Boron 10 is like a neutron magnet. It just loves to absorb those neutral particles.
Neutrons, right. But why is that useful?
This neutron absorbing ability makes boron 10 really important in nuclear reactors.
Nuclear reactors, how so?
Well, inside a reactor, you've got these chain reactions going on, right? Atoms splitting, releasing energy, it's a whole thing.
Yeah, powerful stuff.
And that's where boron 10 comes in.
Mm-hmm.
By soaking up extra neutrons, it acts like a control rod, preventing those reactions from going haywire.
So it keeps things from getting out of hand. Important job.
Absolutely. And then you've got boron 11. That one's more about making energy than controlling it.
Oh, right. You mentioned something about fusion earlier.
Exactly. Fusion, the holy grail of clean energy. It's what powers the sun.
Okay, so how does boron 11 fit into that?
Well, it turns out boron 11 is a really promising fuel for a type of fusion called aneutronic fusion.
Aneutronic. That sounds intense.
It is. Basically, instead of releasing a bunch of neutrons, this type of fusion mainly releases charged particles.
And that's a good thing.
It is. Charged particles are much easier to contain and use for energy production than neutrons.
So boron 11 could be the key to unlocking a clean energy future. That's pretty amazing.
It's definitely a game changer if we can make it work on a large scale.
So boron, it's not just for laundry detergent and cookware anymore.
It's in our kitchens, in our energy, potentially even in the future of medicine with those carboranes. It just goes to show you, there's so much more to discover about the world around us, even in the most unexpected places.
You know what? You're right. This whole deep dive has been eye-opening. Boron has gone from a little brown powder to a total rock star in my book.
Glad to hear it. It's always exciting to see people get fired up about chemistry.
Well, on that note, I think we'll wrap things up here. Thanks for joining us for another deep dive. Until next time, keep exploring and never stop asking questions.